In this video, we are going to construct truth tables. For the case that the truth tables come out to be like always true, that case we call a tautology. That means all combinations return the truth value as true. And the other case, if they all come out to be false, like false to all, so we call a fallacy. It's very rare to be seen for our course. For number 2, complete truth tables for the following. In part A is the negation of P or Q. The 2 is negation, and the shape V there is the connective for the or disjunction. To construct the truth table, since we have two simple statements, P, Q, to find out how many combinations is similar to the way that we determine how many combinations back in chapter 1. For example, for the case that we consider the statement P, there are two options, either true or false. Where we consider the statement Q, if the P is true, Q could be either true or false. Similar way, if P is false, the Q could be either true or false. Therefore, we have 4 combinations. Then this way we can start the table by creating the first 2 columns, the columns for P and Q. And then for the P, we start with true, true, false, false. For the Q, we start with true and then false, true, false, like alternatively. This gonna give us like 4 different combinations for this truth table for the 2 simple statements. Now, to create the next column, as we consider the order of operation, similar way, if you look at the compound statement that we have, the innermost part or the grouping symbol, that is a disjunction, P or Q. We're gonna start with looking at the column for P or Q. And next, we have another column for negation of P or Q. Therefore, we add 2 more columns from the basic first 2 columns. For P or Q, we call the or, both of them false, gonna return the false result. Otherwise, we're gonna have the truth value as true. And the negation is opposite of what is the original truth value. So when we have the 2 columns, the first row, true or true. So this case gonna be true. True or false, gonna be true because at least one of them is true. The third case, false or true. The result gonna be true. The last one, both of them false. The disjunction gonna be false. So this is the case that's gonna make the disjunction to be false only. And then after we get the column for the P or Q, the last column is the column of the result because we're gonna do the negation of the P or Q, or the negation of the one previously. The negation of the true is false. Negation of true is false. Negation of true is false. Negation of false is true. So the last column is the column for the result of this truth table. And not all of them are true. So we can say this is not a tautology. So we can say this compound statement is not a tautology. For the next one, we have the compound statement, not P or not Q, as the order of the connectives. Negation is the least dominant. The or is higher dominant than the negation. So this one, we're going to consider the truth table for not P or not Q. For the two simple statements, we're gonna have the 4 rows or 4 combinations as true, 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 false, false, true, and false, false for the basic 2 columns. And how many columns we can determine from the order of the connected that we have here. We're going to start with finding out what is not P. So the first column going to be not P. And what is the not Q or negation of the Q? And after that, we connect these 2 columns with the connective or. So the last one going to be not P or not Q. From the template or the side work here, so will help us understand how many columns that we have to add. We're going to add 3 more columns. The next one is going to be not P and then not Q. And the last column is the column of the result, which is not P or not Q. Starting with not P is opposite of the truth value for the P. The P column has the truth value as true, true, false, false. So negation P going to be false, false, true, true. Negation of the Q, similar way, we look at the column Q and we write the opposite truth value of what we see. The first row, the Q is true, so then not Q is going to be false, and followed by true. Opposite of the true is false, opposite of false is true. Next, we're going to connect the not P and not Q with the connective or. For the or connective, recall both of them must be false to return the false statement, which the first combination there. So false or false, the result gonna be false. Next, false or true, at least one of them true, the truth value gonna be true, similar to the third combination and the fourth combination. As we look at all 4 combinations, the truth values, they are not all true. If they are not all true, we can say again that this compound statement is not a tautology.